Hello, everyone, and welcome to today's episode number 6 of the eCHO live stream, eBPF and Cilium office hours. Thanks for joining us. I can see some familiar names. It's really nice that we have some regular viewers, so it's great to see you again. We have Christopher, who's moderating today. I see Garcia Hero. I apologise if I'm pronouncing you wrong. Michael, great to see you again. Uh, Jed, I think your handle is unpronounceable, but so I'm going to say hi, Jed. Hi, William. Beatrice, great to see you. Tobias, Marino, there's another familiar name. So if you're joining for the first time, do say hello. We're really happy to have you with us. Also on the chat, I see Joe. He's going to be my guest talking about the Cilium 1.10 release shortly. Hi, Russell. Okay, so before we start really talking about the main topic for today, which is that new Cilium 1.10 release, let's talk about some of the news in the world of eBPF and Cilium. Obviously, the release is the biggest news in Cilium this week. You may or may not be aware that we've released 1.10 on a very, very appropriate date. Yesterday was actually World Bee Day. That seems like a very good day to release an eBPF based project. So we'll come back to Cilium 1.10 shortly, but there are a few other things that I wanted to mention today. Hi VJ, thanks for joining us. In the Windows world, now last week we talked about the fact that Microsoft have released eBPF for Windows. Very exciting to see eBPF on a whole new operating system. If you're interested in that effort, we wanted to mention that there is now a community building up around that project. So highlighting here the issue in the Microsoft eBPF for Windows repo, where they've got a link to the Slack channel, and there's also a regular Zoom meeting being set up. So if you're interested in Windows and in eBPF, do go along and take part in that community. Another bit of news that kind of snuck in a little bit under the radar. So you might have seen this tweet talking about getting started with eBPF using GKE, because Google's data plane v2 is now based on eBPF. How is that done? Well, as you can see further down in this tweet, it is based on Cilium. So we're really excited about that, and I'm sure there'll be more discussion of that in a future date. There's a blog post from Google, and you can see that as of May the 10th, GKE Dataplane v2 is generally available. So that's Cilium being used in a lot more clusters. It's really great to see. I've got one blog post to share with you, or article to share with you this week, which is this article from Red Hat about receive-side scaling with eBPF and CPU map. So as I understand it, this is using XDP to get data out of a network card as fast as possible. Maybe it's the data is coming faster than one CPU can handle it, so the network traffic needs to be fanned out to multiple CPUs, and this article describes doing that using XDP and eBPF to forward packets to the appropriate CPU. All right, hello Michael, that's another person who's joined. If you have recently joined us, do say hello. We're really happy to have you here on eCHO. Okay, I think it's time that we should move to, well, we should welcome our guest. So hi to Joe Stringer, also from Isovalent, one of the Cilium maintainers, and he is here to help us discuss and answer questions about the new release that came out this week. So welcome, Joe.
Hi Liz, happy to be here.
As always, audience, let us know if the audio balance is wrong or anything is strange about the sound. Hopefully we've got it right this week. So yeah, Cilium 1.10 released yesterday. Tell us a bit about what the kind of overall theme of this release is.
So this release, what we're trying to do is provide like better seamless integration with existing clusters with a wider network, particularly in users' own data centers and on-prem environments. So a lot of the features are about not just how Cilium operates and does a great job using eBPF, but also how it then integrates into external pieces as well.
Yeah, I think this is ties in very neatly with what we've seen in the sort of broader cloud native community about, multi-cloud is a real thing. People are, and hybrid cloud is a real thing. People are running workloads in a mixture of like on-prem and managed clusters. So I think it's not surprising that we're seeing demand for that integration kind of to the broader network and to on-prem environments. All right, so there's a lot of things. There is a blog post about this release, and I thoroughly recommend the audience to check that out. We will post a link to that in the show notes. There's a lot of features in this release, but we picked a few that we thought we'd concentrate on today. So where should we start? Should we start with the Egress IP Gateway?
Yeah. Do you want me to share?
Yeah. If you can share the screen, that would be great. Yeah.
Awesome. So so you should see the blog on the screen, and I think the dean's done a great job on the image again, as always. So you can kind of see a little bit about what's going on in this release. We have the Wireguard support, Gopher, jamming out over in the corner here. We have the static egress IP, which is about providing that sort of integration into legacy firewalls. And we have load balancing and BGP service IP announcement on the left-hand side here. So I think we'll touch on quite a few of those.
I think those gives us some great topics to talk about. Let's start with Egress IP Gateway.
Yeah, let's do that. So Egress IP Gateway is really about providing consistent IP addressing outside of the Kubernetes cluster. And so let's say like you want a pod in your Kubernetes cluster to be able to access some legacy database that's in your environment already. If the pod tries to connect, without this feature, typically what will happen is that the traffic from that pod will take on the source address of the node. And then, so if you have 5 different types of pods trying to access that same database, all of those pods seem to be coming from the same source IP address. So that makes it difficult to actually protect that legacy database because you can't differentiate what the traffic looks like depending on who is trying to access that legacy database. And so that's one of the main use cases around this static egress IP and Egress IP Gateway, is to be able to define a CRD that selects some pods in your cluster. And then only those particular pods will take on a particular external IP as the traffic exits that cluster. And that way you can then configure your external firewalls, for instance, or any other services to then do something special based on that IP. And one of the cool things there is that you don't have to change what that firewall, that external component does in terms of, you don't have to teach it about the world of Kubernetes. You don't have to connect it to the Kubernetes API server. As long as you tell it about these particular IPs that you configure, you can actually get it to select specific pods in your cluster by leveraging this feature.
So I guess the CRD is going to define a set of pods that are associated with this IP address using labels. Is that how it's identifying the set of? Okay.
Yeah, so we actually have an example right here. So it's the Cilium egress net policy. And so as traffic egresses the node, we can see we select some pods, and we've just got a pretty standard match labels here. So the example is selecting pods with the default namespace, but this can be any set of labels for your pods.
So you could use like a selector, like you would for selecting pods that are part of a service. So you could assign all of your pods in a service to be associated with one particular egress IP address, egress source IP address.
Yeah, that's right. So once we've selected those particular pods, we choose which destinations we care about. So we're saying only when these particular pods, for instance, access this known external resource, like that this particular app should be talking to this database that's existing elsewhere in your network. And then you decide, okay, well, what is the egress source IP? So what is the IP which the pods that match these labels, what is that IP that this traffic will take on?
So we have a question. Those address, I don't know if this is referring to the this egress source IP address. Does it come from the main pod CIDR or a special CIDR?
Yeah, so maybe if I go back to this diagram, so we have like the 192.168 addressing scheme in the pods on the left-hand side. So this is standard Kubernetes IPAM. So however it is that you've configured that, whether it's through the Kubernetes mechanisms, whether it's through something like the cloud IPAM integration that we do, like AWS IPAM, Azure, and actually now Alibaba Cloud IPAM now with this 1.10 release. So those are all standard sort of pod addresses. Then when it comes to the address that's going outside the cluster here, the 10.24.0.5, that's defined in your CRD. So you can actually pick whichever address that is appropriate for your environment.
Okay. So where that example has 10.24.0.5 in the CRD, that would be the address you would configure.
Yeah, so this will match your CRD, and then you'd have pod label selectors to select which particular pods that you want to apply that basically source NAT as the traffic egress as the cluster. And then once you've configured your CRD to have that IP address, you can then configure the consistent IP in your external service, like your firewall. And that's how it kind of matches these different sides together, and how you get that firewall then to be able to allow traffic only from specific pods with specific labels.
Fantastic. A few more people have joined the call since we've been talking about this egress static IP addresses. So hi to Michael. I don't think we said hi already. Mattia, Grant, and Alex. That's another regular viewer. Nice to see you. Grant's actually just asking a question. Do all of these IP addresses have to be static? And does supporting host names make things really complicated? So I guess there's a question there about whether you could relate to these IP addresses as a DNS name.
Yes, so this in particular is focused on the question of outbound traffic. And so it's, I think, you do have to define ahead of time what those IPs will be. I could imagine setting up in your DNS to say, this particular IP should have this host name associated with it. That's probably a matter of how the integration works with your particular software running in your network. I hope that answers the question.
I think that makes sense to me. And I guess it's also worth sort of revisiting the fact that this is often going to be about integrating with legacy parts of the network, which would have been manually given some IP addresses very likely anyway. So associating an IP address sort of manually to act as this static IP address is probably pretty consistent with the way that things are configured in that world. Right.
Yeah. So, I mean, you're going to need to configure those sort of, for instance, the firewall in this kind of a use case anyway. So this is kind of saying, here's a way that you can then also teach Kubernetes through the CRD. So the person in your organization who's arranging that would probably be the one who would be able to help prepare that CRD for you.
Great. So this is about traffic that's leaving the network, that's being initiated from a pod, egressing to somewhere outside of the cluster. I think if we turn to the next feature that we wanted to highlight, which is BGP, this is about getting external entities being able to reach to route into the cluster, right?
Yeah. So there's kind of a nice balance here of this is almost the other direction, the opposite side of the static egress IP kind of question. So here what we're doing is we are integrating announcement for load balancer IPs, so that when the Kubernetes cluster wants to be able to receive traffic for those particular services, Cilium itself can now advertise those IP addresses to the adjacent router.
And funnily enough, there's a little delay between us speaking and the chat on YouTube. And I think Michael, I'm not going to try and pronounce your surname in case I mess it up, but Michael said, would something like Metal LB for this, but the other way around also be an option? And I think that's describing exactly what we're talking about here with BGP. So yes, Michael, I think this is exactly right. So I've just mentioned Metal LB because Michael brought it up. That's what we're using here to kind of provide that like load balancer service type integration.
Yeah. So what Metal LB does here is it's what we call a BGP speaker. And so it's providing that piece that integrates. So like Cilium on one side is handling the load balancer IP and how we actually handle the traffic as it comes in. But then the question is, how do we let people know how to access this particular IP address? And so Metal LB has the BGP implementation in there. And so when the Cilium part interfaces with that Metal LB library, it's actually a library. It's basically saying here are the IP addresses that we want to advertise onto the network, and there's a way to configure that. And then the Metal LB code is actually doing this, like initiating that control plane connection to your peer routers, and actually passing on that advertisement so that the router next to you then knows, oh, if I receive traffic for this load balancer IP 192.0.2.8, then I should route it to this particular node. Right?
So we're using Metal LB to tell the outside world, I have this IP address. It's over here. Send packets to me if you want to reach that IP address. And then it's actually Cilium that's handling the load balancing side once those packets arrive. In fact, Metal LB is not involved at all.
Yeah, that's right.
Arrive.
So you've got kind of the control plane and data plane. So the control plane piece here for advertising and speaking BGP, that's Metal LB libraries. And then the data plane itself is running in BPF, and that's the same data plane that we've been building, and it's proven and tried and trusted.
Wonderful. Hello, Pablo, who's joined us as well. We've got so many people joining today. That's excellent. Glad to see people are interested in what we're doing in this 1.10 release. All right, is there anything else that we want to say about BGP, or shall we move on to the...
I mean, maybe it might be interesting to folks on the stream to just see like what the configuration looks like.
Yeah, that's a good idea. Yes. Yeah.
So we haven't provided the Kubernetes load balancer resource example in the blog post. That's a fairly standard Kubernetes mechanism. So you should be able to find that fairly easily. The config map that's here is about describing how Cilium is going to connect to those BGP peers, to those routers that are adjacent, and the address pool that will be used for allocating the load balancer IPs. So we have, so it's just another config map. Here we have peers. So each of your router peers that you want to advertise to, you'll specify that. And then you'll have the autonomous system numbers, both for your peer and for yourself. And then secondly, you have the address pools, which we can allocate those load balancer IPs from.
And that autonomous system number, is that related to the BGP protocol?
Yeah. So BGP has this concept of autonomous systems, which is kind of it's almost like an organizational barrier. It's saying these, the IPs, or I guess this region of the network is associated with some kind of a system, some organization that works independently, and I guess depending on how you configure your environment, you may have multiple of these, or you may have one for your organization, and then when you connect to your upstream internet provider, they'll have their own anonymous system number.
Right. Okay. So the internet at large would be divided into a whole series of these autonomous systems.
Yeah, that's right. Yeah.
A question from Tobias is whether there's a way of updating the configuration, the BGP configuration, after it's been installed. And I guess, do we allow these config maps to be changed dynamically?
Yes. So I suspect that you may have to restart the Cilium agent to be able to pick up the new config. But I would probably have to defer you to Slack. I think the folks who work directly on this could definitely answer you that question if you jump on Slack.
So Tobias had followed up with a question: do I need to restart the Cilium operator? I would imagine not the operator, but just the agent. Is that?
Yes, true? I believe this is it. Yeah, it's just running from the agent itself.
Yeah. All right. We weren't going to highlight Alibaba Cloud integration, but since it's there on the screen, I feel like we should just mention we support another, which has been contributed by folks from Alibaba. So that's great that we support another cloud, another public cloud. So the third kind of on-prem feature that we were going to talk about was the standalone load balancer. There's loads of things in this release.
There's so much to scroll through. We would love to touch on all of those.
Yeah.
I know we have spoke about Wireguard in the past. There's lots of exciting stuff for sure.
Oh, here's an actually, before we move on, there was an interesting question from Suresh saying it would be nice if MetalLB, or perhaps the MetalLB integration, used a CRD rather than a config map, so that we could have RBAC controls on that CRD. Which is that's an interesting point. I would love to continue that discussion actually with you on Slack, maybe after the stream, and we can see if we can make sure we understand what the use case and the background on that question is. Yeah. And another MetalLB related question. This is exclusively useful for MetalLB to advertise new service addresses. I guess, this is saying that the Cilium side will be telling MetalLB, here is a service address, and it's advertising it to the outside network. So we're kind of leveraging MetalLB rather than, kind of taking advantage of some capabilities of MetalLB to do that advertisement.
Yeah, I mean that's really about like if there's a project out there that's doing a great job, it makes sense for us to just sort of work with that rather than write our own BGP implementation, for instance.
For sure, yeah. So shout out to the MetalLB maintainers, thank you. Yeah. All right, let's move on to the standalone load balancer. So I guess this is actually really interesting because this is about using Cilium in non-Kubernetes environments, right?
Yeah. So I mean, I think anyone who's been following the project for a while knows that we've been looking into load balancing. We've been focusing on, how do we build a high performance, robust load balancer that's designed with, really with the latest kernel technologies, with eBPF. And so we've solved a lot of problems in the sort of east-west area around, we have a lot of pod churn and aspects like this about Kubernetes and about cloud native environments. And so we've been focusing on kind of solving a lot of those problems. But what we've ended up with is actually a pretty solid basis for just a load balancer that you could run on your own, like just on some node on your network to handle that traffic in a sort of more of a north-south kind of way. So handling the traffic coming into your network.
Fantastic. And one of the features of this is that it's using maglev for that load balancing. And there's a fabulous little animation to describe what maglev is. If anyone is not familiar with it, this, I think, makes it really visual and clear. Yeah, do you want to talk us through what this is showing?
Yeah, I mean, you might as well. We're right here. Yeah, so at the moment, what you have on the screen is when it's random. So when you have connections from the outside world coming in, if the edge node on your network goes down, then basically that edge node on your network is making that selection of where the connection should go to. So it starts out, it will connect through some server. I'll just get my annotations up. So here, and then we connect through to here, right? So we select randomly some backend. But what happens when that particular node goes down with a random selection is that the incoming connection will get routed to a different load balancer. And then that second load balancer doesn't know how the first load balancer made the decision. So instead of linking back to this original backend where the actual connection is going to begin with, instead it sends it to some new backend. And in practice, what this means for the client who's trying to connect in is that when there's an outage in your cluster, the client notices, the client's connection gets broken, and then the client has to then reconnect and actually establish a brand new connection to a different backend in your cluster. So it kind of breaks that that sort of veneer that there's this, something hidden going on behind the screen and you don't need to worry about it. If there's a breakage in your cluster, you do actually expose that to the outside world.
Right. So with maglev, a TCP connection is going to just stay up even if that edge node disappears.
Yeah. So maglev is built on this concept called consistent hashing, which basically allows that first node in the cluster that's handling the load balancing decision to make a consistent selection of that backend, consistent with any other node in load balancing node in the cluster. And so as the connection comes in, first, it hits some particular load balancer and then goes to the back end, and that's fine. When that load balancer goes down and the incoming connection goes to a different load balancer, that second load balancer can then still select that same backend using the consistent hashing. And so I think this blog post, this is actually part of the 1.9 feature blog, goes into a bit more detail on how that works. And so really what's happening here is we're bringing some of those features forward, and we're providing a standalone version of the load balancer that has some of these features like maglev.
Right. And why would someone want to use Cilium as their load balancer in a non-Kubernetes environment?
Yeah, I mean, the basics are, as you scale, then you need some sort of a load balancer to figure out how do you balance those connections across your cluster, right? Now, I think in a lot of environments today, particularly, again, sort of on-premises in users' own data centers rather than in the cloud, you'll often kind of go to one of these large vendors and you'll hand out a large sum of money to get a big expensive box that's then going to do a lot of this stuff. But what we're able to do with Cilium as a standalone load balancer is get commodity hardware. You get the server, you do need to set up the right mix and all that sort of thing. But you can drop Cilium in there, and then you can actually build your own load balancer at a much lower cost.
Right. So replacing some of those expensive pieces of hardware. Apologies to the vendors. All right, great. Audience, if there's questions about any of these features from 1.10 or any other features you'd like us to dive into a bit more, do let us know. I think there was one bonus one we wanted to highlight, which is the new command line interface tool for Cilium, which many of you will have seen kind of demonstrated. We've shown a few previews of this in eCHO before, but it's now officially part of the release. and I think it's going to make life much easier for managing or certainly installing Cilium.
Yes, there's a lot of great stuff here. We have the Cilium cluster-wide status here, so you can just get a good brief overview of what's going on in the cluster and are the components healthy or not. But also, for instance, are you enabling certain features like cluster mesh to connect different clusters together? And beyond that, we've done a lot of work on the Cilium install command. And so I think in the past, what we've had is we've had a lot of guides in the docs that would describe, depending on a particular environment that you have, how do you then install Cilium into that environment? And that's quite Helm-centric, and I think there's a lot of reasons to still use that, particularly if you've got a GitOps style workflow. But for a lot of users, it's actually much easier to be able to just download this Cilium CLI and go Cilium install into your cluster. And what's the Cilium this new Cilium CLI will do is it will probe that cluster to understand what kind of an environment it is. So for instance, if you're running in an AWS environment or if you're running on-prem, and based on that environment, it will pick out what are the best settings. And so some of the things that would previously require you to upfront specify, here are the settings I want because I'm running in this particular environment. Now the Cilium install is able to just provide the best standard approach for you.
Yeah, as somebody coming into Cilium, relatively new, I had tried installing Cilium before, but coming across this CLI, it just made my life much easier. So yeah, I'm a big fan of this as a user experience. And we've also seen this on phones. People have been regular viewers will maybe recognise this picture that we showed last week. I believe we're also now distributing ARM releases as well. So you too can easily run Cilium on your ARM-based devices, like Ricardo here did on his phone. So that's awesome.
Yeah, and of course that's I think it's very, very cool the way that folks will be able to pick up so much stuff in this new release. Both the ARM support, and then we also have this new CLI. You can see it running, really on a real smartphone, and this is just really just for fun. But there's also you can deploy into your AWS Graviton environments, or use the Azure Linux ARM64 pipelines as well. It's all ARM, right? So now that we have ARM64 official images, you should be able to use that in those particular environments as well.
Which is great. And I'm kind of anticipating there being a whole load of new use cases that relate to, Internet of Things and Edge and all these sort of new kinds of devices that we're going to be able to run Cilium on. Michael made a point about, I think, the load balancing algorithm, saying that, I don't know if this is a question or a point, but that random load balancing can be pretty bad performance, and that they'd seen considerably better throughput with Linkerd's algorithm called EWMA, exponentially weighted moving average. So I guess that's really just speaking to what the load balancer algorithm is.
Yeah. I mean, load balancing is a pretty big area, and I think there's a lot of interesting stuff going on in there. How you select the backends, the way you weight them, and a lot of that kind of stuff can have a pretty big impact on your environment, on your ability to handle the load as it comes into your cluster.
Right, which does make sense. So in Cilium, are we currently just doing random allocation?
Yeah, so by default, I think it'll be random, or there's the maglev mode. That's the alternative.
Yes. So I guess with maglev, it's random initially, but once that's been,
it's consistent hash, so it's actually based on the traffic coming in.
Right. Okay.
Yeah, I'm not sure quite how weighting goes with that. Maybe in the future we can have the maglev experts come on and go do a deep dive. I don't know.
That might be a really good topic. So folks, if you want to see maglev in a deep dive, let us know.
Let us know, yeah.
this was an inevitable question given that we had ARM release. Do we have any examples for experimenting on Raspberry Pi? I don't know that we have any kind of official builds for or walkthroughs for Raspberry Pi yet, but
yeah, so we don't have a specific guide, and part of this is, I mean, it doesn't matter to us too much how you deploy your Kubernetes distribution, for instance. We'll run with whatever distribution you like to use. I don't have a Raspberry Pi, but I do have a slightly different board, and I was just using micro-Kubernetes to set up the basics, and then running Cilium on top of that.
Yeah, I've got an ARM-based Mac, so that's that's a whole other challenge. I want to shout out to Aditi, who has also joined as another moderator alongside Christopher. So thanks for joining us, Aditi, and we're really grateful to both of you for helping us out here. Another question came in about Wireguard. So we did an episode with Martinez, I think maybe 3 weeks ago, that really did a deep dive into Wireguard. So I would definitely recommend, Suresh, that you go and check out that episode. But I guess we can probably have a quick look at what we have in the Wireguard release. And this is really all about, I know a little bit about this now because I spoke to Martinez about it just a couple of weeks ago. But this is really about network level encryption, right?
Yeah. Yeah, I'm not really sure quite what to say about it. I guess we support Wireguard now. The way it works is through configuring dedicated devices on each of the nodes, and then Wireguard itself provides the kind of key management pieces. And then your pod-to-pod traffic can be encrypted using Wireguard. I think one of the things we did do actually was to assess the performance with Wireguard and IPsec, so we have a little bit of detail on how that worked, and we have the CNI performance analysis blog post as well, which we posted. I don't know how long ago, it was like maybe a week or so ago. So if you're interested in a deep dive on CNI performance, then that's also something you can look into.
We had an episode of eCHO last week that Thomas came on to do a deep dive into the performance analysis as well. So that's another one you might want to check out if you want more detail on these performance benchmarking that we've been doing. I think really the bottom line there is that, Wireguard and IPsec both have some pros and cons, and one might be more appropriate for you or the other might be more appropriate for you depending on your workloads and your environments and what you need and whether your hardware supports IPsec algorithms. So there's no clear winner between those two, but we support both, so that's great. Okay, so Michael has asked, what's the minimum vanilla kernel version necessary for running Cilium 1.10?
Great question. So Cilium by itself can run on any Linux kernel from 4.9 upwards. I think these days 4.9 is getting a little long in the tooth. So I think you'll probably have better results if you start with a 4.15 or 4.19 kernel even. And as always, the newer the better. But at the same time, I think whatever kernel version it is that comes with your Linux distribution, we'll be able to run on that. There is some limitations on specific features. So we do have a dedicated page in the docs. If you just search for requirements, I think you should be able to find that, which will tell you a little bit about that. So in particular, the kube proxy replacement, I believe, requires a 4.19 kernel or greater. And it looks like ADT has shared the link to those requirements as well.
Fantastic. Thank you, ADT. Great. It turns out Jarno has been running Cilium on Raspberry Pi 400 for some time. So there is prior art out there. Excellent. So Cilium 1.10 is out there. It's in the wild. You can download the releases. You can check out the blog post. You can check out the release notes as well. We'll post a link to both of those in the show notes. Anything else, Joe, that you think we should be mentioning about this new release?
Oh, I think just we're super excited to get this out, and if you have feedback for us, would love to hear it. Yeah,
Yeah, and
excited to be able to ship it.
And I guess we should also say a big thank you to everyone who's contributed. Many people have made contributions outside of the kind of core maintainers. Thanks to the core maintainers, but also thank you to everyone who's raised an issue, got in touch, given us feedback, or even submitted a pull request. We really appreciate that. Okay, so I think unless we get any late breaking questions, I think that will be a good wrap up for this edition on the 1.10 release. I will mention that next week's eCHO is going to be at the earlier time. So we alternate between a West Coast friendly time zone and a kind of Europe friendly time zone. So we're back to Europe, which is very relevant because we have a European guest. We're going to have Laurent Bernay from Datadog joining us next week. And we hope very much to see all of our viewers there again next week. So thank you very much for joining us. Thank you to Joe. Big virtual round of applause to Joe for sharing his expertise and knowledge with us today. And we will see you all again very soon on eCHO. Bye for now.